All right, let's do 2.2. We're going to start with number 25. So on number 25, it says to write the equation of a line. So I automatically write down this anytime anyone says to write the equation of a line. I want to be parallel to this. So that means parallel is going to mean same slope. So that means my slope needs to be 3. And I want to go through 4, 9. 4, 9. I want to go through 4, 9, which means that's my x1, y1. So my y1 is 9, my slope is 3, my x1 is 4, and there's the equation of my line. If I want it to be nicer, I could distribute and then add my 9. Subtract my 9. It's going to be minus 21. Okay. So just to double check. Oh, what did I do? Oh, I screwed that up. This should have been minus 9. Let me be careful. So now when I add 9, it's minus 3. Okay, sorry. Cool. So that's 25. Let me look at number 29. 29 is find the point at which this line intersects this line, minus 5. And notice where those two lines intersect is going to be when they have the same y values. So in other words, when this y value and this y value, or their outputs, are equal. So I can add 3x to both sides, subtract 5, and then if you divide, you end up getting negative 2. So negative 2 should be our answer to number 29. Okay, so negative 2 is that x coordinate. Notice they asked find the point at which. So if my x is negative 2, then I can use either one to find the associated y. So if x is equal to negative 2, f of negative 2 is going to give me 1. They intersect at x is equal to at the point negative 2, 1. That's a point on both lines. So that's 29. Let's go to 49. 49, it tells me that P of t is equal to negative 2 plus 3t. It says to graph. Well, the first thing I notice is that I could write it like this. So if I have to graph it, this is the y-intercept, and this is the slope. So that means my y-intercept is going to be down here at negative 2. So the point 0, negative 2 is going to be on my graph. But then, every time, if my slope is 3 over 1, every time I walk up 1, I'm going to go up 3. So I think that means that the point right here, every time I go over 1, I should go up 3. Trust me, it's not drawn to scale. Well, if I was going to, let me draw it to scale. So this should be 1, 2, 3. So if I go over 1, I should go up 1, 2, 3. So that would be the equation of my line, where now it has the point 1 on it. Cool. So that is 49. Then if I look for 51, 51 is to draw the line x is equal to negative 2. So if all my x coordinates are negative 2, then I must be a vertical line. So I go back here to x is equal to negative 2, and I draw this vertical line. And that's what it would be. So that's 51. I go to 53. And so for 53, it says q of x is equal to 3. That's the same as y is equal to 3. So when I draw this one, I go up 1, 2, 3. and I just draw a horizontal line at y is equal to 3. So that's what that one looks like. All the outputs for every point are 3. That would be that set of points. That's 53. Then I look at number 55. Now, why is that different? Well, because we don't like the form. A lot of math and science is about form. In this case, I've got two fractions. So I want to get rid of a 3 in the bottom and a 4 in the bottom. So I'm going to multiply both sides by the least common multiple, which is 12. 12 hits this. It gives me 12 x over 3. It distributes and hits this and gives me minus 12 y over 4. And on this side, it just gives me 12. So over here, these cancel out and give me negative 3y. These cancel out and give me 4x. Right? So now if I want to, I can move the 3y over here and the 12 over here. So I'm close. And now you just divide everything through by 3. So I get 4/3 of an x minus 4. And so now I'm ready to graph. I know that my m is 4/3. My b is negative 4. So if my intercept is 1, 2, 3, 4, so there's 0, negative 4. And it seems like every time I go 1, 2, 3, every time I go 1, 2, 3 forward, I go up 4. So I think that means that when you plug in 3, you'd better get out 0. So 3, 0 is a point on the line. So if I do this, there we go. It's a pretty straight line. All right. That's 55. Then I go to 61. And then 61 just wants to remind you for this graph right here, bam, if that is 61, let me crop that to make it look a little better. Boop, 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 boop. So if that is 61, then notice that what all those points have in common is they have the same y value. So this would just be y is equal to 3. But then on 63, so this is 61, for 63, that one just turns out to be, bam. So use photo, let me crop this one. Oh, I gotta be careful. I did the wrong one, we're not gonna do that again. So for 63, it's the graph above the number. So it should be that one. Use photo. And then I'm going to crop. I can go over here. Ramp. Ramp. So it should look like this. Well, notice for that line, what do they all have in common? Well, the x is equal to negative 3. So that would be 63. Again, 63 would be x is equal to negative 3. So then after 63, we try number 71. And what is 71 asking? It's saying that you want to find the equation that is perpendicular to g of x is equal to negative 0.01x plus 2.01 through the point 1, 2. So I guess this is going to be my x1, y1. And it wants to be perpendicular. Perpendicular means opposite reciprocal slope. So my slope right here is negative 1/1000. So it's negative 1/100th. So, wow. Opposite reciprocal slope, not slope or whatever I wrote. So opposite reciprocal would be a positive 100 over 1. In other words, a positive 100. So m is equal to 100, and x1 is equal to 1, y1 is equal to 2, with y minus y1 is equal to mx minus x1. And so if I plug in y2, my slope of 100, x minus x1. I guess you get 100x minus 100 is equal to y minus 2. So y is equal to 100x minus 98 is what we should have gotten for 71. Okay, and then after 71, then we're going to do 74 and be done. 74, it says a car rental company. So plan A, it's $30 per day and an additional 0.18 or 18 cents per mile. Plan B, it's just a flat rate of $50 per day, no matter what mileage you have. So if we're talking about the cost, it wants to know how many miles do you have to drive for plan B to save you money. I think since it's only talking about miles changing, we want to fix 1 day. So we're going to just talk about 1 day. So for 1 day, this would be constant, and plan B would be y is equal to a constant 50. For this one, y is going to be equal to an initial value of 30 plus 18 cents every mile. So in this case, maybe we let m, no, that'll be confusing. We'll let x is miles. So when are they break even? When would you save money? Well, let's think about breaking even. So same cost. So cost the same at when 50 is set equal to 0.18x plus 30. So in other words, when you subtract, you're going to get when 20 is equal to 0.18x's. So in other words, x is equal to 20 divided by 0.18. I don't even need a computer. I could do 20 divided by 18/100ths. Oh yeah, I do. I do. It's not going to be as easy as I thought. So let's take, I don't need it, but I want it. 20 divided by 0.18. Oh, 20 divided by 0.18, thank you, number lock, is x is going to be equal to 111.1 going on forever. So x is approximately equal to 111 miles is where they break even. So after 111.1 going on forever miles. So I'll say after 112 miles, comma, which one is better? Well, when you look at the graph, one is going to be a constant 50, and the other one is going to look like this, where its y-intercept is down here at 30, but eventually, because it's rising at a rate of every 1 mile, you add 18 cents, then it's, in the very beginning, it looks like the $30 one's going to be cheaper, but when you hit this amount right here, which is going to be 111.1 miles, then the blue starts to be more expensive. So after 112 miles, I'll make sure that's clear. It's the blue one, plan B. Plan B is cheaper. Right? Cool, great work. Have a great day.